Hello everyone, good morning beta. Today we want to start our next topic. Okay, that we have done already the dimension analysis. Okay, before dimension analysis we have done our physical world, different type of the forces we have done, quantities we have done, physical, non-physical, then physical type we have done. After that we have done dimension formula, dimensional analysis, use of these dimension formula. Okay, now our next topic we are starting of this unit, that is significant figure. Okay, for point of view of any exam, that is not so much important before, because 4 and 5 year this is not coming in our exam, but we will do something about this one. What are the significant figures? Okay, significant figures beta, these are the numbers, figure number of any quantity that we are measuring, any quantity, then at which number we are measuring, by which instrument, then we will find the significant figure. Okay, now we will read about this one. Those digit, here we are doing those digit which are known reliable, plus one additional digit, plus one additional digit, that is your significant figure. Okay, for example, if you want to measure this one, size of this pen you want to measure, then here we are using the scale. Okay, with help of the scale we are using this one, then measurement of the scale, then it will give you two significant number only, and maybe three also. Okay, for example, its size will be your, then if we are taking here, first one we are doing significant figure. Significant figure, that is our reliable number. Okay, reliable means if you want to measure size of any, here we are taking any beaker, then here size of this one in this liquid, here let we are taking this minuscule size. Okay, and their length of this one here given here in your 1 2 3 4 5 and 6, their size is given like this one. Then in between having their points, here value can be beta between there till 1 point only. Okay, for example, here you want to measure this one with help of the scale, then like this one we will measure its size with help of the scale, then we can write its value maybe here 6.5. Okay, then we can measure with help of the scale its value with the one digit only after the point. Okay, then if we are writing here after this one is a not your complete proper position till here 6 to 7, then we can measure with help of the scale only till here one digit only after the point. Okay, if we are writing here there 4 5 3 2 like this one, 4 example we are writing here, and we are taking the reading with help of the scale, then we can't take the reading like this one. Okay, up to these value we can't take the reading of this one, that's why it is wrong for the measurement by using our scale. So this one we can't include for our significant number. Here significant number we can write there 6.5, so its significant figure we can write there 2 will be there. Understood or not? Okay, then if we are doing the measurement of any object, for example measurement of this pen we are doing with help of the scale, scale will give you 2 reading only, then 1 to 15, that scale, small scale 1 to 15, then in point if will be there, then till 1 point only it will give the value only. Okay, for example, if I am writing here 12.5, if we are measuring any value 12.5, then its significant number will be our 3 only. Okay, all non-zero numbers are the significant figure. Okay, we will do this one with help of the different rules of the significant, where how we can write its figure. So here we will do the rule of the significant figure. First one, our non-zero digit always counted. Okay, any number you are writing in decimal or without decimal, so all are without zero, all we will include in our significant figure. For example, here written 234.5. Then here significant of this one will be 2, 1, 2, 3, 4 our significant figure. All are non-zero numbers that are the in your decimal or non-decimal, that we will call it 4 significant figure. Next, your 0 in between always counted. Okay, in any numbers coming 0 between them, then always will become in your significant figure. For example, here written 200.03. Okay, here you are non-zero, here also non-zero, between them coming your zeros, that's why we will count in the significant number. So here we can write there 1, 2, 3, 4, 5 our significant figure. Okay, for example, if I am writing here 2004, okay, here front and back there is a non-zero number, but between them having 0, that's why here significant figure will be our 4 only. Okay, 4 our significant figure here. Next our beta leading 0. Okay, leading 0 means in the any number having 0 front of this one, means left hand side of the number, then we will not include for the significant figure. Okay, for example, leading 0 never counted. For example, this one written 0.0165. Okay, here front of this one 165, if 0 will be left side of any number, then we will not include in our significant figure. Okay, so for example, here this one 0.0 we will not include the 0, then here 1, 2, 3, its significant figure we will take 3 only. Okay, if I am writing for example 0.0002 is there, so here 0 all are left side of this one, then we will write here significant number will be our 1 only. Okay, these are the rule of the significant figure to find by using this one. Another rule also will be there to find out this one. Now here all the zeros to the right of the decimal point, all the zeros to the right of the decimal points are significant figure. Here in last one rule we have done left hand side of the figure, then we will not include in a significant figure, but our this one right of the decimal point, any decimal point is there, then on the right side of the decimal point if here 0 is there, then we will include in our significant figure. For example, here given your 165 centimeter, here 16.0 centimeter. Okay, then there will be our 3, its significant figure will be 3, 1, 2 and 3 significant, but here beta 0 is there after the point, then here significant figure will be 4. Okay, we can't leave this one 0 because beta here 0 is there. What is the meaning if is 0? Means here we can measure this one after the decimal also. Okay, for example, I told you that the scale you are taking, if you are taking its reading, if any object having size is coming your 10 centimeter for example, but after 10 its length will be increased, and after 10 also we can measure it, so its value we will write with a 10.0. Okay, means here significant number will be 3. Okay, 10.0 means after the decimal maybe can have any value. Okay, here 0 is there, means 0. If size will be 0.1, then we can write it 10.1. Okay, 10.1. Okay, means in future if your size will be changed, you want to change its size, then after the decimal maybe its value 0, 1, 2, 3 like this one. Okay, mean in instrument having available this type of the counting, that we can count after the decimal also of these value, that's why here we are writing significant number is 3 also. Okay, so after the decimal any 0 will be there, then we will include our significant figure. So here we can write beta, here for this one we can write there 3 significant figure, and for it after the decimal having 0, then we will include in significant figure, then here will be our 4 significant figure. Clear to everyone? Now before the decimal we are saying that there is a no counted in our significant, but after this one right side of the number, then we'll include in our significant figure. Next rule to find out significant figure: numbers of the significant figures does not depend upon the system of the unit. Okay, if we are writing any number that not depend upon our the system of the units, means any number if we are writing, then that same number if you are writing in your different quantity, then significant figure will not change there. Clear? Okay, then if I am writing here, for example, this one we are writing here. Okay, any number is 16.4 centimeter is there, comma here we can convert there this 1 centimeter into our meter. Okay, in our meter we are converting, then this one number we can write in meter like this one form 0.64. Okay, and same number we are converting in kilometer, then how we can convert like this one we can convert? Yes or no? Here same number beta, but our quantity system of unit we are changing. First we are changing into meter, centimeter, kilometer, but our significant figure our will remain same only. Okay, all having 3 significant. Here having 3 significant, 1, 2, 3. 3 significant figure. If we are converting this number in term of the meter, then here also our significant figure will be 3 only. Okay, now this one same number we are converting into kilometer, then here also significant number figure will be 3 only. It will be not changed as we are changing our unit of any number. Okay, if we are moving our covering our 100 meter distance, then if you want to convert into your centimeter, then its significant number 3 only will be there. If you are changing this unit, then its significant figure will be not affected there. Okay, so this one our rule of the significant figure. Okay, let beta we are trying to do some questions related our significant figures to find their following their number are given, then here you have to find out significant figures. Okay, first one here, follow your rule of the significant figure. Okay, here first question 0.007 is given, then here find the significant figure. How you can find beta? We done already, that is any zeros will be there left hand side of any number, then their significant figure will be equal to your 1 only. Okay, so here zeros are there left side of this one, number is 1 only, so it's significant figure. Here we are writing beta significant figure of these number here will be 1 only for this one. Okay, if your zeros will be left side of the number, then we will not include for the significant. If right hand side there, then we will include there. Okay, so here significant number of this now number will be 1. Here this one number is given, then here you have to find out significant figure. Then how we can find beta? Check there 1, 2, 3 and their 0 is there. I told you 0 if there after this one, then we will not include this one, but after point will be there, then we will include this one. So here your significant figure will be 4. Okay, now next our 0.0005567. Okay, here any unit will be there of the number, that is significant figures are not depend upon the units. If you are changing units, that keeping same only, then figure will be remain same only. Okay, so here 0.00557, before this one all zeros are left side of our non-zero value, so here will be your 1, 2, 3. Here significant figure of this one will be our 3 only. Okay, if the 0 will be after 7, then we will include in our significant figure. Now here next question beta, here you have to find out significant figure. Check here, from initially first one number our non-zero, last number also our non-zero, any zeros will be between non-zeros value, then will include in our significant figure. This rule also we have done. So keep here 1, 2, 3, 4, 5, 6. Here 6 number are there and both zeros are all 3 zeros are between the number. That's why here significant figure will be 6 only. Okay, like this one we will find, beta. Keep your rule in your mind properly, then easily you can tell there are significant figures. Now next one question here, 2.000 there. Okay, means after the decimal, beta, if zeros are there na, means we can measure that points by that instrument. That's why we are taking there in a significant figure. Understood? Okay, means significant figure those values which are reliable, which we can measure by using our instrument. That figure are known as the significant figures. Okay, here after the decimal, beta, 000 are there. If you are measuring, means example, if you are measuring this one value from any instrument, till your 3 decimal, we can measure the value by using that instrument. That's why here significant figure of this one value will be 4. 1, 2, 3, 4. Okay, here significant figure will be 4. Like this one way, beta, we can find the significant figure of our any value. Okay, now your last topic our of this unit, that is error. Okay, this one our significant figure, how we can find out significant figure, this one. Now next our error. Okay, what are the errors? Errors, beta, if we are doing any the practical value, we are finding practically in our lab, then we are finding different value by using our instrument. Yes or no? Okay, but if we are doing experimentally any an instrument, you are finding the value of any instrument, then that will be some different from our real value. Okay, which one is given in our theoretical, then if we are doing that theoretical value, you are doing the practically, then some change from our true value, theoretical value, then that change is known as our error. Okay, understood? So here we will read what is error. Then error is the measurement is equal to an error in the measurement. Okay, we are doing any measurement practically in our lab, that to the difference between the true value and measured value. Okay, true value means theoretical value which written in our books only, that is true value, and our measured value, measured means which we are performing in our measured value, that we are doing in lab. Okay, in our lab practically we are doing, that is some change from the true value to measured value, that change is known as a error. So here how we can find this one error? Error equal to true value minus your measured value. True value minus measured value, that is our error only. Okay, then that error, beta, can be a two type, according to our system, can be. Then here first one here random error, second our systematic error. Okay, random error, that can be due to careless of the students. Yes or no? Okay, that due to physically change, that also can be error will be there in instrument. If we are doing the any electrical experiment, then due to the high heating effect of the on the wire, then also resistance can be changed or not change of the wire, then also some error will be there from the true value. Okay, so random error randomly can be there. Second, our systematic error. Okay, if we are doing our work systematic, then also due to the some problem in our instrument, then also will become this error. That's why we are calling it systematic error. Okay, now we will do this one, our first one, your sister, this one random error, then error due to the random and unpredictable region. Okay, randomly this one happening, we don't know about this one error, how this one is there, we can't predict this one, this can be happen. Okay, so this one our random error, unpredictable region. Second, our can't be eliminated, can only be minimized. We can't be eliminated. We are doing that experiment, any experiment again and again, but some change will be there in our practical value from our true value, that we can minimize by using our practically. Okay, but can't we eliminate this type of the error? Next, our take the load of the reading and take the average. Okay, how we can remove this one? We have to take many readings, and you have to find the average of this one. Okay, for example, this pen is there, I am taking the size of this pen again and again, then its value will be coming maybe different from our practical value. Okay, if given that the size is 15 centimeter, but due to some randomly error, okay, we don't know about this one, we can't predict this type of the error, but if we will take the value of this one size of this pen, then maybe some change in the decimal, some change will be there. Okay, then again its value will be changing, some change like this one 15.1002, like this one 15.100, 15.1.003, like this one small change is there again and again. So how we can remove this one? You have to take better load of the readings of that instrument and find the average of the error. Okay, then we can find how much error is there. Now next, our different eye position will be give different reading. Yes or no? If you are doing practically any you are doing any practical of any instrument, then if your eye is moving here and there, okay, different position of the eye, then our value of that instrument also will be different. If you will keep your eye on the center of the instrument, then position also will be a mostly accurate. Okay, but as you will change the position of your eyes, then your value of the practical, that is different from our true value. Okay, so this one error will be our random error. Okay, now next, our systematic error that caused either by faulty instrument. Okay, this one error is not by your unpredictable, that can be due to our instrument, your instrument is not properly, then method of experimentation also, that you are applying the method during the experiment, then also this type of the error will be there. Okay, next, consistent and repeatable. If you are repeating our experiment, then also this type of the error will be there. Okay, for example, electrically, if we are using our any instrument, then due to the heating effect, if we are again using our instrument for any experiment, due to the heating effect for the long time, there will be some change in our reading. Okay, so this our instrument error, and that error our systematic error, that can be removed if we will take this one with some gap. Zero error beta, if we are you have seen also any, for example, any weighing machine, on the weighing machine without weight show some weight. Yes or no? We are keeping any weighing machine, then on the weighing machine, on the weighing machine, then beta zero error means we are using any weighing machine, then without measurement of the weight, then they are having the value of the weighing machine. Yes or no? You are not standing on the weighing machine, then also that will show some weight. That is our zero error. Okay, we can change it. Okay, then we can take it again on the zero, then measure it, then your actual weight will be shown. Okay, so this type of our zero error also. And scale size change due to the summer and winter season, beta, that is you are measuring any size of an instrument, that we can change due to the our season also, due to, because in the summer that will be more heating effect, in winter will be cold so much, that also due to this one instrument will be their error. Okay, thank you so much.